Welcome to physics class. In this video, I'll be talking about product of vector. We have two cases under product of vector. The first case is taken to be the scalar product and the second case is taken to be the vector product. The first case, which is also known as the dot product, and the second case, which is also known as the cross product. Right? The dot product is called the scalar product, while the cross product is taken to be the vector product. So what actually happens is that there is differences between the scalar product and also the vector product. Suppose we have vector A, which is equal AXI, right? Then plus AYJ, right? And also we have vector B, which is equal BXI, right? Plus BYJ. Then what is going to be the dot product and what is going to be the cross product? Right? We all know that in the case of vector, they have magnitude and direction. But scalar, they have just only magnitude but no direction. So in this case, as far as dot product is concerned, we are going to focus on only the magnitude but not the direction. But as far as the cross product is concerned, we are going to focus on both the magnitude and direction. Now the dot product is expressed as A dot B. The cross product is expressed as vector A cross vector B. The dot product can also be AB but not A cross B. This arrow actually denotes vector in a particular direction. Now what's going to be our dot product? Our dot product is going to be A dot B, which is equal AX multiplied by BX into bracket I. I'm multiplying this and this together, plus open another bracket AY, right? Multiply by BY into bracket J. Let's say everything here it include another component which is AZK and this also BZK. Then the scalar product is going to be plus again AZ multiplied by BZ. Then we have our K here. Then what of the vector product? Vector product is taken to be A cross A vector cross B vector, vector A cross vector B. Right? So vector A cross vector B, in this case, will actually be magnitude of A, right? Then multiply by magnitude of B. So there is differences between the dot product and also the scalar product of a vector. Suppose our dot product is inclined at an angle theta, right? Our dot product is inclined at an angle theta. Then vector AB, right? AB, A dot B will be equal AB cos theta if it is inclined at an angle. Then suppose we have vector, we have the dot product. What's going to be the dot product if the dot product, what's going to be the cross product if the cross product is inclined at an angle? So the angle between the vector products can be expressed as vector A cross vector B, which is equal AB sin theta. So in terms of the dot product, which is also known as scalar product, if the dot product is inclined at an angle theta, then we are going to have it to be A dot B, which is equal AB cos theta. But as far as cross product is concerned, we are going to have it to be vector A multiplied by vector B, which is equals to AB sin theta. So we can actually express our vector A, vector AB as AB, vector A, that is our cross product, as A. We can actually express A cross B as AB. Then let's go ahead and calculate. Let's say we are asked to calculate for angle between two vector. Let's say we are asked to calculate for the angle between two vector. Let's suppose vector A is equal AXI plus AYJ plus AZK, right? And vector B is equal BXI, right? Then plus BYJ, right? Then plus BZK. So the angle between the two vectors is given as cos theta equal A dot B divided by A cross B. That is the dot product over the cross product. So the major differences between the two method of calculating the product of vector is actually the for vector A, for the cross product, we are going to have it to be magnitude of A multiplied by magnitude of B. Right? So if vector A, if it is inclined at angle, if the cross product is inclined at an angle, we are going to express it as AB sin theta. But as far as the dot product is concerned, if it is inclined at an angle, we are going to have it to be AB cos theta. Now let's move to the question. So let's check the first question I'm having here. The question is that vector A is in the direction of the x-axis and axis unit as its magnitude, while vector B of magnitude 4 legs lies in the x to y plane and makes an angle of 30 degrees with the x-axis. Find the product of vector A and vector B. So what actually happens is that whenever we have vector A and vector B and we're asked to find the product, but both are actually inclined at a particular angle to each other, then the product is taken to be vector A and vector B, which is equal AB. Then to specify the angle, or the angle we are going to use in this case, since the vector is in the direction of x-axis and it makes an angle with the x-axis, so here we will be having it to be AB cos theta, right? So and here we have our vector A to be 6 and vector B to be 4. Then here we are going to have it to be vector A multiplied by vector B will be equal 6 multiplied by 4 cos theta is 30 degrees, right? Then here we are going to have it to be 24 cos 30, right? And this should be approximately 20.78, right? Which is also, I can approximate to 20.8 units, right? So the reason why I actually choose to make use of scalar products here or dot product is that since the vector makes an angle with the x-axis, and as far as x component is concerned, I'm always deal with cos. That's why I choose to use my horizontal instead of vertical. That's my cos theta instead of sin theta. A box lies on an oily surface. This should be oily surface. On an oily surface through a displacement of minus 3 meter d, right? While a steady force F, which is equal to I, right, plus minus 6, right? Then we have it to be J all into brackets Newton, pushes against it. Calculate the work done. We are asked to calculate for the work done, right? Then after that, if the initial kinetic energy of the box before before displacement is 10. That is, if the initial kinetic energy, that is our K naught, equals to 10 joule, right? So what is the final kinetic energy? We are asked to calculate for the final kinetic energy. So in this case now, that will be Kf unknown. So let's go ahead and calculate the question. So here we are going to have our work done equal F times D, which is force times distance. So our work done equal force, which is 2I, right? Then plus into brackets minus 6J, right? Then into brackets Newton, then multiply by what? By our distance, which is minus 3 meter J. So this is going to be, here we are going to have to be, in this case, we have two components, which is I and J, but we have only J here. It shows that our I, in this case, is 0I. So 2I multiplied by 0I is actually 0, right? Then minus 6, right? Multiplied by minus 3. Right? That's actually something. But from the question, I'm having 2 Newton I, right? And also 6, right? Then after that, I'm having my distance to be minus 3G. Right? So here I will just go ahead and what? I multiply. My work equal 2 multiplied by 0 is 0, right? Then I'm having it to be plus minus 6 multiplied by minus 3, which is 18. Right? So our work done in this case is 18 joule. So after that, we are asked to find if the initial kinetic energy of the box before displacement is 10 joule. What is the final kinetic energy? We are asked to calculate for the final kinetic energy if the initial kinetic energy is actually 10 joule. So to calculate for the final kinetic energy, we know that work done equals to change in kinetic energy, right? Then work done equals to final kinetic energy minus initial kinetic energy. Our work done here is 18 joule, which is equals to final kinetic energy is unknown minus initial, which is 10. Then we are going to have our final kinetic energy to be 18 joule plus 10 joule, which in this case, our final kinetic energy equals to 28 joule. And that's the answer. So if you find this video helpful, do well to click on the subscription button and drop a comment in the comment section below. Don't forget to click on the notification button so that you get notified whenever I drop another video. Thanks for watching.